One of the handiest and most important forms of an equation of a line is the point-slope equation. This is so handy because the slope-intercept form means you have to have a very special point. You have to have the intercept. The point-slope equation can work with any point. So if I know that the line goes through a point x sub 1, y sub 1, so it could be something like it goes through the point 7, negative 8, then the point-slope equation says y minus, and then the y coordinate here, y minus negative 8. Well, minus and negative is plus 8. And I don't know, let's make up a slope of 2. And x minus 7. This is a equation of a line that has a slope of 2 and goes to the point 7, negative 8. So it's very handy, and that's a beautiful equation. You don't need to do much with it after that. Sometimes we add y sub 1 to both sides and put it on this side of the equation. This is handier if you're using it in something like a spreadsheet where you need to have y alone. So let's write equations of a line that has a certain slope and goes to a certain point. So what I do is I write my template. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. Tests will be open book, so write these in your notes. And then now what I do is I just make a little note to myself, which one is x sub 1, which one's y sub 1, and now I just fill in the blanks. I have y sub 1 is negative 11, so let's plug it in. And again, I can plug it in using minus a negative 11 is minus negative is plus. The slope of 4/13, x minus, and then now I plug in the value 5. That's it. That's all you have to do. The next one says we want to find an equation that goes to these 2 points, and so I have a point, but I don't have a slope, so I need to figure out my slope. Now, many of you have learned the slope equation, x2 minus that's y2 minus y1 over x2. I'm not even going to do that. I don't like doing that. I always think of slope as rise over run. So let me put my points into a table. It helps me see what's going on. So my job is to figure out how much it rises, and that's the change in y's. And it looks like it went from 6, that's a regular 6, to negative 12. So it looks like it went down. This is why I like doing it this way, because I can tell that it goes down. If I use the equation, I'm bound to make subtraction negative mistakes. So I know it went down. Well, it went down 6 and went down 12 more, so it must have gone down 18. Here it went up 6. That's my run. So my slope is rise over run. So it's negative 18 over 6, which is negative 3. So let's finish this. We have an equation of y minus y sub 1. And which one's our y sub 1? Well, we can take our pick. It doesn't matter. Let's call this y sub 1. So y minus 6 is equal to negative 3 times x minus 3, which is our x sub 1. This one has a slope of 5 and goes to this point. Now we could use y minus y sub 1 is equal to the slope times x minus x sub 1. But do you notice something? 0, 8 is a point up here on the axis. That's the y-intercept. So we didn't have to use the point-slope form. We could have just written this as 5x plus 8. The y equals mx plus b. You could have written it that way. Both of those are fine. So when it comes time to graphing an equation, you could graph an equation, any equation, doesn't have to be linear, any equation, just by plotting some points. So for example, we can just take the first equation and start plugging in some points. Let's make it negative 1, 1, 2, 3, and just start plugging these in. So 6 this is kind of annoying. Calculating, no, I'm not going to do it this way. Plugging in points always works, and if you ever get confused, you can always go back to that. But it's just kind of annoying. If we find a point and a slope, then if I know a point and I know a slope, I know its rise and run, I could find the next point. Connect the dots, we got ourselves a line. So if we just find 1 point or maybe 2 points, we're good. So in this case, I always make a little table, X and Y. And here, I want to find the easiest thing to calculate. And the easiest thing to calculate I see is if I plug in 0 for X, then I get Y equals, well, this part goes away and I get Y equals 6. So now I could graph 0, 6. Hey, that's the y-intercept. And then I could graph a slope of -3. Down 3 over 1, down 3 over 1, so forth. So I showed you this table. You probably could have figured out anyway that this is already in slope-intercept form. This is y is equal to mx plus b, but I did b plus mx. And so the m was -3, the slope of -3, the b was 6. And you could have just looked at it and done it, but if you don't see it right away, just try to find 1 point and graph it from there. Now here, the easiest point to plug in, if you look at this side, I can plug in some number that'll get rid of everything on this side. That's really easy. I don't have to deal with the -3 force. So the way you get rid of everything on this side is to try to make this 0, because then 0 times -3 force, it all goes away. So the easiest number to plug in is -7. And let me do that. If I plug in -7 here, -7 plus 7 is 0. That part's okay. 0. Hey, this whole side is gone. That's why I pick -7. And now look how easy it is just to add 1 to both sides. So that's a really easy point. So now once again, I have a point and a slope, so I can graph that. Now once again, you could recognize this if you do this enough times. You recognize this. This equation that was given is just in the point slope form. And you could just look at it and see what x sub 1 and y sub 1 is. Because look at that. This must have been the y value, y1. And if you look at this, negative x sub 1 must have been 7, so -7 must have been x. And so you could either just look at the equation and figure out what x sub 1 and y sub 1 is, or, once again, the table is always going to work for you. Find a point. Now this next one I'm going to do a similar way. I'm going to make a table. And what's easy to plug in? Well, I'm going to plug in 0 for x and see what you get. If you plug in 0 for x, that first term goes away. And look how easy that is to calculate, because now I can just divide both sides by -4, and I can figure that out. So one easy one is to plug in 0 for x, but it's also easy to plug in 0 for y. And by the way, what I usually do is, if I'm plugging in 0 for y, I don't usually rewrite it again. I just kind of cross it off. Maybe I put my finger over it. I kind of cover it up. Because if I plug in 0 for y, then I have that term go away. And now if I make that term go away, I divide both sides by 3, I get -4 for x. I can kind of do that in my head. So if you have this in what's called standard form, then you can just plot 2 points and you're done. You don't need to plot a whole bunch of points. So 0, 3 is someplace over here. I'll change the color. 0, 3 is someplace over there. -4, 0 is someplace over here. So your graph looks something like that. Let's practice. Y equals mx plus b. I'll make a little table. X, y, plug in 0 for x. And we'll see that this term goes away. 0, -5. And then I have the slope of -1/2. So the rise must be -1, and the run must be 2. So it goes -1 is the rise, the run must be 2, and just connect the dots. Next one, I can make a table of values. The easiest number to plug in is to get this to go away. That means I can plug in -4. So y must be 3. I add 3 to both sides. And let me show you a second way to do it. The second way to do this is just recognize y sub 1 must have been -3. And y sub 1 must be 3. That's what I got. And -x1 is 4, so x sub 1 is -4. So I have something to graph. Here we go. I have the graph. I graph the point -4, 3. And once again, I have a slope to deal with. I go up 2, rises 2. It's like 2 over 1. So rises 2, runs 1. Rises 2, runs 1. So this is my graph. And the last one, I'm going to show just the quick way. Y sub 1 must be -3. X sub 1 must be 2. So let me use this in green. We have 2, -3. And I have a slope of 7/3. So go up 7 and over 3. There's my line. So if we go backwards, we need to find an equation for these lines. Let's start with C. C, we can see the y-intercept. So we don't even need point slope form for this. We can just use y equals mx plus b or b plus mx. Let me write it b plus mx just for fun. The b is 2. The b is 2, and the slope, it goes down 1 over 3, so down 1 over 3. And I probably could just get rid of that plus negative, so just minus 1/3 x. Okay, that's the equation for that first one. Let's do the green one. The green one, I can't see a y-intercept clearly, so I'm not going to rely on that. But it does go through some points. Let me write the point that it goes through, and then that'll help me write the equation. The point that this goes through is -1, 2. So -1 is my x sub 1. 2 must be my y sub 1. So write my template. And now I fill it in. Oh, what's my slope? My slope is 1, 2, 3, 1, 2. So it goes up 3 over 2. Rises 3, runs 2. X sub 1 is -1. So minus and -1 is +1. That's for graph A. Let me skip D. It's a slope-intercept form again. Let's go to B, and B has an equation. Since all the y values are the same, all the y values are equal to 6, this is the equation.